from this is a work made by Smith and Stevenson in 2013. So as we can see, this is the shipping pattern, and as we all know, the global warming will decrease the sea ice extension, and this can increase the shipping traffic, changing the pattern of shipping traffic. So this is a model that they have done, Smith and Stevenson, by September mid-century 2050. This is the projected navigation routes to cross the Arctic Ocean, and as we can see, it's clearly different as the other one as a baseline. So we can see here, this is the pattern can clearly change, crossing all the North Pole, and using the Northwest Passage, which affects and crosses most Canadian Arctic. So all these changes can create a greater opportunity for movement and introduction of species. How? Like through ballast water in the ships and through hull fouling, so species that can be attached to the hull of the ships. So given this scenario, the objective of the study is to predict the potential habitat suitability for a subset of benthic aquatic invasive species and to assess the probability of establishment in the Canadian Arctic. How do we do this? We have to first choose what are the species that we will be working with, and with this we choose them according to the relative high risk of introduction, according to a protocol proposed by Ricciardi and Rasmussen in '98, which uses documented information. This documented information is about the ports and the connection to ports. So in this case, all information about species that are connected to Canadian Arctic ports, biological characteristics, and invasive history. So we gathered all this information and we arrived to a list of 8 species with having relative high risk of introduction, which are the Japanese skeleton shrimp, the green crab, the soft-shell clam, the periwinkle, the bay barnacle, the coffin box bryozoan, the red king crab, and the orange sheath tunicate. It is really, really important for you to have in mind during all the presentation that these 8 species are not present now in the Canadian Arctic. They are present in ports that are connected to Canadian Arctic ports. So during the presentation, I will be presenting results as a model, as an example for the green crab, and then at the end I will be presenting like a sum up of all the results of all 8 species. So how do we do this? We have to model the species, and we use the species distribution models. These are tools to predict the potential habitat suitability and distribution to forecast the capacity for invasion by potential invasive species, and we do this to assess a relative risk. There are several different kinds of models, and the one that we chose is MaxEnt, which is maximum entropy, made by Phillips et al. In 2006. And it uses presence-only information of the record of the species to predict the likelihood of habitat suitability or presence across an area of interest. So, how does this model work? First, we have to train the model. To train the model, there are 2 different inputs of information. The first input is the species records of, so it's where the species have been recorded. We did this at a global scale using either the native and the introduced range. And we took the information from global biodiversity databases, such as the GBIF, OBIS, and invasive species list and literature. And then we have to relate these species records to the environmental characteristics that they exist in this position. So we gather information of environmental variables at a 1 degree resolution, a 30-year data set taken from the World Ocean Atlas and the Sea Ice Data Center. And we used different variables such as bathymetry, temperature, salinity, and ice concentration. So once we have all that, the models are trained, are tested, and validated. After that, we have to project the model into the area that we are interested, so in this case the Canadian Arctic, and into a climate change scenario. So we used a model developed by University of Manitoba which is a projection of the Arctic Ocean conditions using the models MEROP 5 and LIMO. The projected time of this model is 2050, so mid-century, and the scenario that it uses is the 4.5 IPCC model, which is an intermediate model that predicts that by the end of the century there will be an increase of 2.4 degrees. And the information is in higher resolution. And as you can see, we also use the variable characteristics, environmental characteristics, but not at a global scale, but using the Arctic and the North Atlantic. But we use the same environmental characteristics as the one with the models were trained. So it's bathymetry, temperature, salinity, and ice concentration. So once we run the model, what did we find? I will be presenting, as I said, the information, the results about the green crab. So we get a map like this one, where we can see in green the predicted geographic potential of the green crab as it is modeled by the species distribution modeling. Here in blue, we can see the actual native distribution, and in yellow, the actual introduced distribution. So as you can see, the model can predict where the species is present. Then we do the same for the future, and we overlap the present with the future to get a map like this one. So in gray, you see the suitable habitat that is in the present and in the future for this species. In green, all the habitat that is suitable only in the present, and in red, the habitat that is suitable only in the future. So the result for the green crab shows that there is a general trend, so there is an increased poleware suitability, and we also calculated the centroid of distribution of the species. So for the green crab, in this case, it was here, the centroid of the distribution, and we calculated the difference between the centroid in the present and the centroid in the future. And we calculated this having a result of a shift through the northeast by 140 kilometers, and it showed also a gain in habitat suitability of close of 7%. So one thing that is really interesting in this prediction is that, as we are seeing here, there will be for the future a new suitable